Okay, so today we're going to be talking about our inverse trig ratio. So yesterday we had sine, cosine, tangent with a missing side. Our inverse comes with a missing angle. So our first example, you should see this on your Desmos. Is that true? It's like, I think the second slide or something. Okay, so you have number 1, and it says which trig ratio, right? So we're going to find out which one we use. So do you see how x is my missing, it's the missing angle this time, right? Okay, so I'm looking to find what x is. It's a missing side. I need to figure out how 15 and 24 are related to that. So is 15 opposite, adjacent, or hypotenuse? It is opposite of my missing angle. And what about 24? That is my hypotenuse. So if I have opposite and hypotenuse, which trig ratio am I using? Sine. Opposite and hypotenuse are sine. Okay, so answer your first question, please. So I have sine of my angle, right? Do I know my angle this time? No. So I'm going to fill in x because I don't know my angle. So sine of x equals... Question. Yes. Okay, so I have sine of x equals opposite over hypotenuse, which is 15 over 24, right? Remember doing this last year? Yes or no? Okay, so now I need to solve for x. X isn't by itself, so I have to apply the inverse trig function to it. So remember, inverse trig is with my little -1 exponent. So that means I have x equals inverse sine of 15 over 24. Okay, do you remember seeing that last year? Okay. Now, another way I can write inverse sine, and I want you just to be familiar with it, is arc sine. So inverse sine and arc sine mean the same thing. Is that okay so far? Yes or no? Yes? Okay. So, are we all ready to type this into Desmos? Do you know how to type it into Desmos? Okay, so there's a couple ways you can do it. First is you can type sine, then shift 6, -1, because that gives me an exponent. The next way I can do it is I can come to my keyboard. You see I have my keyboard down here? Are you watching me? I can click my functions. Which function do I need? Sine inverse. And what was my number? 15? 15 over 24? Okay. I can do 15 divided by 24. Is that correct? Is that my answer?
No. Wait, no.
No, why not? What did I forget to do?
You forgot the degree.
I forgot to change it to degrees. Now, is that a correct answer?
Yes.
Yeah. So you see how I did inverse sine right there? Let's say I type arc sine. You see how it typed that for me?
Yeah.
Okay. What if I do 15 divided... Whoops, that's not 15. My fingers are too fat to do this. 15, that's still not a 5, divided by 24. Do you see how I got the same answer for this? Okay, so sine inverse and arc sine mean the same thing. Yes, question? The division sign. So the slash on the question mark is the division sign. Or the other way is if you pull up the keyboard, it has a division sign on it. So to get my final answer, I'm going to have to round, right? So x is, what was it? It was 38.6. Does the 8 round up? It was 38.682, so then that stays at 8 like this. And it's degrees because I'm looking for a degree. Okay, now let's look at our second one. Here's my missing angle now. How are 8 and 11 related to that? What is 8? Opposite, adjacent, or hypotenuse? And then 11, opposite, adjacent, hypotenuse. So adjacent and hypotenuse means what trig ratio? Good. So I have cosine of x equals adjacent over hypotenuse. So now what do I have to apply? What do I have to do? I need to find the inverse of cosine. So I have x equals cosine inverse of 8 over 11. And now that's something I can plug into my calculator and find. So can you do that for me, please? And again, you can do cosine inverse, you can do arc cosine, because these are equivalent. So we have x is 43.34 degrees, right? So if you want to make a little note to yourself, I have sine inverse is equivalent to arc sine. I have cosine inverse is equivalent to what? If sine inverse is the same as arc sine, cosine inverse is the same as arc cosine, and tangent inverse is the same as what? Arc tangent, okay? Does it matter which one of these you use? No, but I want you to be familiar because I remember being in pre-calculus as a student and a question came up on a test and said, find the arc tangent of blah, blah, blah. And I was like, I don't know what that is, and that's not my button on my calculator, it's tangent inverse. And my teacher afterwards, she was like, oh, I forgot to tell you guys that. So I missed like 3 questions because I didn't know arc cosine and arc sine and arc tangent meant the same thing as inverse, okay? No, it was here when I was a student here. That's what happened. She doesn't work here anymore. Okay, we're going to do our next example. On your next slide, it should have 3 and 4. Is that true?
No.
Your next slide should be 3, right? We're going to start with 3. Okay, this is the picture, right? Yes, example 3. Okay, so we're going to find the indicated missing measures. So again, I'm missing x. And I know you're talking because you're asking for help in your groups, okay? But please keep it down. I do like that you're asking your group members for help, but let's all make sure we're still focusing at the same time. How is 37 related to x? What is it? Adjacent. Good, it's right next to it. And what about 20? So if I have opposite and adjacent, which trig ratio is that? Tangent. Good. So I have tangent x equals opposite over adjacent. So I have x equals tangent inverse of opposite over adjacent. Can you find that answer for me? Okay, so it sounds like we have 28.39 degrees, yes? Can you try the next one for me from the beginning by yourself? Okay, so on number 4, we should have seen that it's cosine. Is that true? So we have cosine of x equals 18 over 23. So x is arc cosine or inverse cosine of 18 over 23. So what is my degree here? X is what? I saw a lot of you with an answer. What is it?
38.5.
Do we agree with that? 38.50 degrees? Because it was 0.4999, I think, and that rounds up. Yes or no? Okay, can you move on and do the last 2 that you have? Okay, finish the last 2, please, and we'll go over them. Okay, so for number 5, which trig ratio did I use? Was it sine, cosine, or tangent? This one was sine of x equals 40 over 41, yes? So x equals sine inverse of 40 over 41. So what was the answer? 77.31 degrees? Okay. Do we agree with that? Okay. Next, number 6. Which trig ratio was that? Good, I had opposite and adjacent, so I have tangent of x equals 7 over 5, right?
Yeah.
Okay, so I have x equals, let's write arctan this time, because remember, it means the same thing, of 7 over 5. So what was my degree measure? 54 point what? 46 degrees? Like that?
Yeah.
What did it round to? Did I not round it?
Yeah, because the number next to 6 is a 2. So.
Yeah, it's 54.462, so it stays and it doesn't round. It's at 0.46. If it was 0.465, it rounds up, but since it's 0.462, it stays. Okay, I have 2 more for you. Are you ready for them? These ones aren't on the Desmos now, so you need to focus up here. Okay, ready for the last 2?
Yeah.
Okay, so my first one is a typical SBAC question once it shows up. Okay, so it's not on the Desmos anymore. Where is it? Okay, here it is. This is a typical SBAC question. This is a word problem, isn't it? We like word problems
Not really.
once we learn how to do them. Okay, so it says, in each triangle ABC, angle C is a right angle. Find the value of tangent A if A equals 6, C equals 10. And then it says, hint, draw a triangle. Will that hint part be there on a test necessarily? No. But if it says, I'm talking about a triangle, and there's no triangle drawn, shouldn't I start by drawing a triangle? And what kind of triangle does it tell me I have? Oh, it says a right angle, so that means I have a right triangle. So can you make a right triangle on your paper for me? Okay. Can you make a right triangle? Now, does it have to look like this one? No, it can be flipped or it can be upside down as long as we label it correctly, right? But here is how I'm going to label mine. So, it said the triangle name is ABC. So that means my angles are A, angle B, and angle C. What do I know so far about any of my angles?
A is 6, C and 10.
Not quite. It says angle C is a... So can't I label that C right now? Yes. Can you do that for me if you haven't? Okay. Now, what are my other 2 angles? A and B. So I'm going to label A and B. Do I know those angle measures? No, not quite. So you said A is 6, right? But that's a little a, isn't it? It's a lowercase a, isn't it? So when I have a lowercase a and a lowercase c, that tells me I have a side measure. So typically, and I don't know if you guys learned this because we don't have like a geometry class, but when I took geometry, this is what we learned. And if you learned it last year and you forgot, let's refresh it. The large or the uppercase letter is our angle measure and the lowercase letter is the side measure, okay? So little a, we're going to look at angle A, which is right here. Whatever is opposite from that is side A. So that means opposite is going to be little a. Does that make sense? Where is little b going to be? Between A and C, right here. And then where is little c? Opposite from C, which is my hypotenuse. Does that make sense how I labeled this? No, it doesn't? Okay. So do you see where my angle measures are? A, B, and C? Their corresponding sides are whatever is opposite from them. So opposite of A is going to be little a. Opposite of B is little b. And opposite of C is little c. Does that make more sense now? Okay, are we all on the same page now? Okay, so I have some more information. It tells me that A equals 6. So that means this side measure is 6, right? What else does it tell me? C equals 10, right? And what is it asking me to find? It says find the value of tangent A. Does it say find the measure of angle A? No, it says just find tangent A. So that means I literally need to find the trig ratio for tangent A. So what is tangent again? It's what over what? Opposite over adjacent, right? So, what is opposite from A? Good. 6 is opposite from A. What is adjacent to A?
T.
Isn't this adjacent to A? Do I know what that number is? No, I know it's my B value, right? But is it okay to have two variables in the question like that? No, so we need to figure out what is our B value, okay? So now, this is where our favorite thing ever for the right triangles comes in. Because my IM3 classes were like, right triangle, right triangle. They would do the same exact thing every time they saw a right triangle. What can you do if you have two sides of a right triangle to find the third side? I heard one of you say it. The Pythagorean theorem. Do you remember that? A squared plus B squared equals C squared. Do we remember that vaguely? Okay, so listen please. The Pythagorean theorem is used when we have two sides and we're missing the third of a right angle. Remember, A squared plus B squared equals C squared. Do I know what A is? Do I know one of my legs? Yeah, it's 6. Do I know my other leg? No. And do I know C? Do I know my hypotenuse? Yes. Okay. So what is 6 squared? Good. And I still have B squared. And what is 10 squared? Perfect. Can you help me solve for B? Subtract 36. I heard that. Good. And I have B squared equals... What's 100 minus 36? 64. So then what does B equal? Good. B equals 8 then. So let's plug that in over here. So that means tangent A equals 6 over 8. And if I simplify that, what do I get? 3 over 4. Is that okay? Okay. Here's our last thing once it loads again. It says find the value of the trig function indicated. It says find sine theta if cosine theta equals 4/5. Have you seen theta before? Have you seen theta before? Okay, this symbol right here is theta. Okay, it's just a Greek letter, and we use it as a placeholder for angles most of the time, okay? So if we don't know our angle, a lot of the time we're going to call it theta. So I know I have sine and cosine, which tells me I probably have a triangle. So do you think I should draw a right triangle? Yeah, I'm going to draw another one. Did I give you a hint to draw it this time? No, so you just needed to know I need a right triangle. Okay, so it says find sine theta if cosine theta equals 4/5. So which angle do I want to make theta? Do I want to do the top one or the bottom one? Are we okay with doing the bottom one? Okay. I guess that's okay. So it's like literally just a little 0 with a horizontal bar through it. So I know cosine theta is 4 over 5. And again, what's my ratio for cosine? It's what over what? Cosine is adjacent over hypotenuse, right? So if I know that's 4/5, that means adjacent to theta is what number then? 4. And that means my hypotenuse is what? 5. Good. Now I need to find sine theta. That's the new thing that I'm looking for. So sine theta is going to be what over what? Opposite over hypotenuse, right? Do I know either of those measures? The hypotenuse is what? Do I know what's opposite theta though? No, but can I find it? Yes, using what? The Pythagorean theorem again. So I have a squared plus b squared equals c squared. Okay, do I know one of my legs? Yes. What is the first measure of one of my legs? It's 4. Do I know my second leg? No, that's what I'm looking for. And do I know my hypotenuse? It's what? Good. So that means I have 16 plus b squared equals 25. So I'm going to subtract 16. So b squared equals what? What's 25 minus 16? It's kind of small. It's less than 10. 9. So what does that mean b is? So that means I have 3, and then sine theta is 3/5. Is that okay? Okay, now before we move on, what do we notice about our 3 sides of our right triangle right here? What are the 3 measures? What are the 3 side lengths of this right triangle? The 3 side lengths are 3, 4, and 5, yes? Or no? Do you agree with me? The 3 side lengths are 3, 4, and 5? So if you see 3, 4, and 5, 6, 8, and 10, any multiple of that is going to be a right triangle. So if you see maybe 4/5, you can think about, oh, I know in a triangle, if 4 and 5 are the sides, the third side is 3. Or if you see 3/5, I know the third side is 4 because this is it's a Pythagorean triple, I think is what it's called. So that just means that a squared plus b squared equals c squared, and it's an even, nice, neat number, okay? So you don't have to remember that as long as you know to use the Pythagorean theorem. But to cut down on some time, if you see a right triangle with 3, 4, and 5, or any combination of those two, you can figure out what the third side is pretty easily if you remember that, okay?